Okay, so we study the two indeterminate forms, 0 by 0 and infinity by infinity. इन्फिनिटी बाय इन्फिनिटी फॉर्म भी हुआ है ना अपना?
Yes, ma'am.
Yes, ma'am.
Yes, okay. So here for these two 0 by 0 and infinity form, directly we apply L'Hospital rule.
Yes, ma'am. 18 to
0 into
infinity भी हुआ
infinity पण झालाय मॅम.
है. Yeah, ma'am.
0 raised to infinity भी हुआ है. 0 raised to infinity.
नाही 0
0
into
into
infinity.
infinity form. Okay. So we have completed the 0 into infinity also. Okay.
Repeat करता ना एक बार.
0 into infinity form भी हुआ. Yes. So we have completed these three forms: 0 by 0, infinity by infinity, and 0 into infinity form. Now the next form is infinity minus infinity. We know that when the limit is in 0 by 0 or infinity by infinity form, then you will directly apply L'Hospital rule for the two forms. If it is 0 by 0 or infinity by infinity, you will directly apply the L'Hospital rule. You can find out derivative of numerator, derivative of denominator, and then we apply the limit. If limit is finite, that is our answer. If it is not, then again we will find out the second derivative of numerator and denominator function, and then we apply the L'Hospital rule. But when the function is in 0 into infinity form, when the function is 0 into infinity form, then in that case, 1 minute. Okay. Yes, when the form is 0 into infinity form, when the limit is in 0 into infinity form, then we directly will not apply for this L'Hospital rule. First, we have to convert this into 0 by 0 or infinity by infinity. We write the function fx into gx in the form as fx upon 1 upon gx or gx upon 1 upon fx. Okay, by writing this function fx into gx in one of the form, it will get converted into 0 by 0 or infinity by infinity form, and then after that we apply the L'Hospital rule. So directly for this 0 into infinity form, we will not apply the L'Hospital rule. By writing the function fx into gx in this form, fx upon 1 by gx or gx upon 1 by fx, it will get converted into either 0 by 0 or infinity by infinity, and then we apply the L'Hospital rule. Okay. Now the fourth form is infinity minus infinity form. Okay. So the next form, infinity minus infinity form. Suppose limit of the function fx as x tends to a is infinity, and limit of the second function gx as x tends to a, that is also infinity. Means limit of both the functions tends to infinity is equal to infinity. Then limit of the function fx minus gx. If you take subtraction of these two functions and then apply the limit as x tends to a, then this will be limit fx minus limit gx. So what is limit fx? That is infinity. Limit gx, that is also infinity. So this limit fx minus gx as x tends to a takes the form infinity minus infinity. Okay. Subtraction of these two functions takes the form infinity minus infinity. Now directly here again we will not apply L hospital rule. We will simplify the bracket expression. Okay. After simplification of this bracket expression, it will get converted into 0 by 0 or infinity by infinity. And then after that we apply the L hospital rule. See here, put it bracket expression, that is fx minus g. So we simplify this bracket expression. Simplify this fx minus gx. Whatever is the bracket expression, simplify this by cross multiplying or by taking LCM. You can simplify this. After simplifying this, it reduces to 0 by 0 form. It reduces to 0 by 0 or infinity by infinity form. And then after that, you will apply for L hospital. Okay. So for 0 into infinity and infinity minus infinity, directly we will not apply L hospital rule. First we convert that into 0 by 0 or infinity by infinity form, and then we will apply the L hospital rule. Okay. For infinity minus infinity form, we simplify the bracket expression first, then it get converted into either this or this form, and then after that we will apply the L hospital rule. Okay. So now solving example on this. Evaluate limit x tends to pi by 2. Evaluate limit x tends to pi by 2 of sec x minus tan x. Sec x minus tan x. Now to evaluate this limit, sec x minus tan x as x tends to pi by 2. So first of all, we will see the example or limit of this function is in which form. So for that, we will put value of x is equal to pi by 2. See here, sec of pi by 2 minus tan of pi by 2. Put the value of x as pi by 2. Okay, so this becomes sec pi by 2 minus tan pi by 2. We know that tan pi by 2 is infinity. And sec pi by 2, sec is nothing but 1 upon cos pi by 2. Now cos pi by 2 is 0, so 1 by 0, any number divided by 0, that is again infinity. So this is infinity minus infinity form. So the given limit is in infinity minus infinity form. So we identify the form of the problem. So now it is in infinity minus infinity form. We will reduce it into 0 by 0 or infinity by infinity form. Okay. Directly here we will not apply L hospital rule. So we can write this limit as limit x tends to pi by 2. 1 by sec can be written as 1 upon cos. Okay. So this is 1 upon cos of x minus tan x can be written as sin x upon cos x. So this is sin x upon cos of x. Okay. Now see here, for the subtraction of the function, denominator is same. See, denominator is same, that is cos x. So for this we write one denominator, that is cos of x. Okay. Then in numerator will be 1 minus sin x. So we write this as 1 minus sin x whole term divided by cos x. Both the term having same denominator, so divide by cos of x. Now, what will happen if you put x is equal to pi by 2 in this? So this becomes 1 minus sin pi by 2 divided by cos pi by 2. In this limit, in this function, if you apply the limit, when x tends to pi by 2, this will reduces 2. See here, 1 minus sin pi by 2 upon cos pi by 2. Now cos pi by 2 is 0 and 1 minus sin pi by 2 is 1. So 1 minus 1 0 and it is 0. So now this is converted into 0 by 0 form. This is now in 0 by 0 form, and therefore we apply L hospital rule here. Therefore, by using L hospital rule, by applying L hospital rule, we take derivative of numerator function and denominator function. So this limit will be limit x tends to pi by 2 of d by dx of 1 minus sin x divided by d by dx of cos of x. Take the derivative of numerator function as well as denominator function. So this is equal to derivative of 1 minus sin x with respect to x, that is for 1 derivative is 0, so limit x tends to pi by 2 of derivative of 1 is 0 minus derivative of sin x is cos x divided by derivative of cos x is minus sin x. Okay, and now this is limit x tends to pi by 2 of cos x upon sin x, that is cot of x. So limit x tends to pi by 2 of cot x. Now put the value of x is equal to pi by 2. This becomes cot pi by 2. Cot pi by 2. That is nothing but 1 upon tan pi by 2. 1 upon tan pi by 2. Now tan pi by 2 is infinity. So this is 1 by infinity and 1 by infinity is 0. Okay. So our limit value is 0. Therefore, L limit is equal to 0. Or here also you can put the value of this x is equal to pi by 2. This becomes cos pi by 2 upon sin pi by 2. Sin pi by 2 is 1, cos pi by 2 is 0. So this will give you 0 upon 1, that is also 0. Okay. So here limit is equal to 0. So in this way we can solve the problems of infinity by infinity form. Okay. We consider another problem. Evaluate the limit x tends to 1. Evaluate limit x tends to 1 of x upon x minus 1, x upon x minus 1 minus 1 upon log of x, 1 upon log of x. Okay. First of all, we will check the form of this function by substituting x is equal to 1 in this. So this becomes 1 upon 1 minus 1 minus 1 upon log of 1. Put the value of x equal to 1. 1 upon 1 minus 1 minus 1 upon log 1. So this is 1 by 0 minus 1 upon log 1 is also 0. 1 by 0 is infinity. Again 1 by 0 is infinity. So now the problem is in infinity minus infinity form. The given limit is now in infinity minus infinity form. So we identify the form, it is infinity minus infinity. Directly we will not apply for L'Hospital rule. We will simplify the bracket expression first of all. So this is equal to limit x tends to 1 here. How to simplify the bracket expression here? By using LCM or by taking cross multiplication, you can simplify this bracket expression. So here we will cross multiply this. So x into log of x minus 1 into x minus 1. That is same, x minus 1 divided by x minus 1 into log of x. Okay. By taking LCM or by cross multiplication, you can simplify this bracket expression. Now, see here, after simplifying this bracket expression by cross multiplication, x log x minus x minus 1 upon x minus 1 into log of x. So if you apply for limit, then see the form, it get converted into, so if you apply limit 1 into log of 1 minus 1 minus 1 divided by 1 minus 1 into log of 1. So now see the form, this log 1 is 0, minus 1 minus 1 is 0, 1 minus 1 is 0, log 1 is 0. So 0 by 0. So the now problem is in 0 by 0 form. When we apply limit in simplification form, so the given limit is now in 0 by 0 form. So you can apply L'Hospital rule now for this function. Okay? So this is now converted into 0 by 0 form. We convert infinity minus infinity into 0 by 0 form, and now we will solve this by using L'Hospital rule. Therefore, by applying L'Hospital rule, in short I write LHR, L'Hospital rule, we have find out limit of numerator as well derivative of numerator function as well as denominator function. So numerator function d by dx of x into log of x minus x plus 1, okay, minus x plus 1 divided by x minus 1 into log of x. Take the derivative of numerator as well as denominator function. Okay. Now we can find out derivative of numerator as well as denominator function. So see here, this is nothing but it is equal to d by dx of limit x tends to 1 of d by dx of each and every term, d by dx of x into log of x into log of x minus d by dx of x plus d by dx of 1 divided by d by dx of x minus 1 into log of x. Okay. Taking derivative of each and every term of numerator divided by derivative of denominator term. Now see here, for the derivative of this x into log of x, we will apply product rule. Similarly, for the derivative of x minus 1 into log of x, we will use the product rule to differentiate this with respect to x. So see here, what will be the derivative of x into log of x? D by dx of x into log of x. See here, d by dx of x into log of x. We know that product rule, d by dx of uv is given by u into v dash plus v into u dash. This is our product rule. So apply the rule here, u is equal to x and v is equal to log of x. Okay. So if u equal to x, v is log x, use the derivative rule. U into v dash, u is x into d by dx of v, that is log of x, plus v, that is log of x, into d by dx of u, that is x. Okay. So x into derivative of log x with respect to x is 1 by x, plus log x and derivative of x with respect to x is 1. So this become here x get cancelled with each other, x and x get cancelled, we get 1 plus log of x. Okay, so this is d by dx of x into log x. Derivative of x into log x is 1 plus log x. So we can put the value here, limit x tends to 1 of x 1 plus log of x. Okay, this is d by dx of x into log of x minus d by dx of x with respect to x, that is again 1, and d by dx of 1 constant, that is again 0. Okay, so we get the numerator as 1 plus log x minus 1 plus 0 divided by, now derivative of this denominator function with respect to x. So here using same rule, d by dx of x minus 1 into log of x. Product rule. So assume u is x minus 1, v is equal to log x. Differentiate this with respect to x. So what will be the derivative? U into v dash, that is x minus 1 into derivative of log x, that is 1 by x, plus v into u dash, that is log of x into derivative of this x minus 1 with respect to x, that is 1 only, 1 minus 0, that is 1. So this is x minus 1 upon x plus log of x. Okay, this is the derivative of denominator. So we write this as x minus 1 upon x plus log of x. Now see here which terms get cancelled. So this is limit x tends to 1 of 1 with minus 1 get cancelled. So in numerator we get log of x divided by. In denominator we can divide this numerator separately by denominator x. So x minus 1 by x. So x minus 1 upon x is nothing but x upon x minus 1 by x. So x upon x is 1 minus 1 by x plus log of x. Okay. So we get this simplified form. Now in this, if you apply the limit, what will happen? This becomes log of 1 divided by 1 minus 1 plus log of 1. Now 1 get cancel, 1 minus 1 get cancel, and log 1 is 0. So this is 0 by 0 form. Okay. So when we apply limit here in this function, then this become log 1, that is 0, upon 1 minus 1 they get cancelled, again log 1, that is 0. So now this is again in 0 by 0 form. Limit is not finite here, we get 0 by 0 form. So here we apply L'Hospital rule for this function. Okay, we apply L'Hospital rule for this function. We will find out derivative of numerator as well as derivative of denominator function with respect to x. So by applying L'Hospital rule, by using L'Hospital rule, we have if L is limit x tends to 1 of d by dx of log x divided by d by dx of 1 minus 1 by x plus log of x. Okay. Now find out the derivative. Derivative of log x with respect to x is 1 by x divided by derivative of 1 is 0. Derivative of minus 1 by x is minus 1 by x square, and derivative of log x is here 1 by x. Okay. Now find out the limit. If you put the value of x is equal to 1, so this becomes 1 upon 1 divided by this will be plus 1 plus 1. So this is 1 by 1 means 1 and 1 plus 1 is 2. So half is the finite value. So L is equal to half. Half is the limit of the given problem. So L is equal to half. Half is our finite number. So this is our limit of the given problem. Okay. Now consider the third example, next problem on infinity by infinity rule. Okay. So prove that limit x tends to 0. Prove that limit x tends to 0 of a upon x minus cot of x upon a is equal to 0. A upon x minus cot of x by a, that is equal to 0. Now here in this problem, a is some constant here. We don't know value of a. So if you put the value of x is equal to 0, this a by 0, and cot of 0 by a, that is again infinity minus infinity form. If you simplify this by putting x is equal to 0. But here cot angle is x by x. So if we assume x by a is suppose if x by a is 1 and as limit x tends to 0, therefore limit in terms of y that also tends to 0. If x tends to 0, then y also tends to 0. Okay. Therefore, this limit can be converted in terms of y, and this can be written as limit instead of x tends to 0, here we write y tends to 0. If x by a is y, then a by x will be 1 by 1 minus this cot angle that become cot of y only. Okay. Now limit y tends to 0, 1 upon y, cot y can be written as cos y upon sin y. This can be solved. Okay. Now see here, if you directly here x is equal to 0, this become a upon 0, that is infinity, minus cot of x by a, that is 0 upon a. Okay, cot of 0 upon a. Now cot of 0 upon a, that is cot of infinity. Cot of infinity. Okay, that is infinity. So this is infinity minus infinity form. But for the two values, that is x and a, x is the variable here and a is some constant. So for this angle x by a, if we assume the third variable, that is y, next variable y, x by a, suppose it is y, Then as x tends to 0, this y also tends to 0. Okay. Y also tends to 0. Okay. Therefore, here this form will be infinity minus infinity form. This is 1 by y. If x by a is y, then a by x will be 1 by y minus this part of x by a, part of x by a that becomes part of y. Now, for this part y, we can write cos y upon sin y, 1 by y as it is. And see here, if you put the value of y is equal to 0, this becomes 1 by 0, that is infinity, minus, this is cos of 0 is 1, divided by sin 0 is 0, that is again infinity. So this is now infinity minus infinity form. Okay. So to get infinity minus infinity, we take this x by a as y, and as x tends to 0, y also tends to 0. So limit will be in the form of y. So this is now infinity minus infinity form. Directly here we will not solve this by using L'Hospital rule. So we have to simplify this bracket expression. And to simplify this bracket expression, we use cross multiplication. So by using cross multiplication, see the form which we get by using cross multiplication to solve this bracket expression. This is 1 into sin y, that becomes sin y minus y into cos y divided by y into sin y. Okay. Now, put the value of y equal to 0, this becomes sin 0, that is 0, minus y is equal to 0, but cos 0 is 1, so 0 into 1, that is again 0, divided by y 0, sin 0 is 0. So 0 by 0 form here we are getting. Okay. So by applying y equal to 0, here the form of the problem is 0 by 0 form. And now we can apply L'Hospital rule. Therefore, by using L'Hospital rule, we will find out derivative of numerator as well as derivative of denominator function. Okay. So you can find out that derivative. Simplify this. We okay. So this equal to limit y tends to 0 d by dy. Now here we have to differentiate this with respect to y. Okay. Because limit is now y tends to 0. This is derivative of sin y minus y into cos y divided by d by dy y into sin y. Now to find out this derivative, so this is limit y tends to 0 d by dy of sin y minus d by dy of y into cos y divided by d by dy of y into sin y. Now for the second derivative, we will use the product rule to differentiate this with respect to y. So limit y tends to 0, derivative of sin y is cos y minus, apply product rule to differentiate this with respect to y. Again here, apply product rule to differentiate this with respect to y. So here, using u into v rule, u into v dash, that is y into derivative of cos y, that is minus sin y, plus v is sin cos y, derivative of y with respect to y is 1, divided by, assuming u as y, v is sin y, use the product rule. So u into v dash, y into derivative of sin y, that is cos y, plus v is sin y into derivative of y with respect to y. Okay. Now simplify this. What we obtained, simplify this. This should be minus here. No, makes sense. So simplify this. What we get. After simplification, we obtain this as limit y tends to 0 of cos y minus minus that becomes plus y into sin y and minus cos y divided by y into cos y plus sin y. Now see here, cos y and minus cos y get cancelled, so we get y into sin y divided by y into cos y plus sin y. So when we apply limit as y tends to 0, then this is 0 into sin 0, that is again 0 divided by 0 into cos 0, that is cos 0 is 1, 1 into 0, 0, and sin y is again 0. So that is again we get is 0 by 0 form. So again you will apply the L'Hospital rule again. Okay? So again you have to apply L'Hospital rule for this problem, and when we apply again L'Hospital rule, then we get the answer as 0. 0 का आंसर लेना है। प्रूव क्या कराया है? प्रूव दैट लिमिट ऑफ दिस, हमें प्रूव क्या करना है? प्रूव दैट लिमिट ऑफ दिस इज इक्वल टू 0. आंसर इज गिवन टू यू. Okay, so to prove that it is equal to 0. But even if your limit is not finite, it occurs in 0 by 0 form. So again we will apply L'Hospital rule, and for this we will find out derivative of numerator as well as denominator functions. So take again derivative. So d by dy of y into sin y upon d by dy of y into cos y plus sin y. Now if we differentiate this with respect to y using product rule, what we obtain? See here, use the product rule, y into derivative of sin y cos y plus sin y into 1 divided by y into minus sin y plus cos y into 1 plus sin y derivative is cos y. And now apply the limit. Limit y tends to 0. So this is 0 into cos 0 is 1 plus sin y. Sin y is 0 divided by. This is 0. Sin 0 is 0. Y is 0 plus cos 0 is 1 and plus cos 0 is 1. So this is 0 divided by 2. Now it is not in 0 by 0 form. This is 0 and denominator is 2. So 0 by 2, that is again 0. So answer is 0 here. This is finite value. Answer is 0. This is not in 0 by 0 form. This is 0 by 2. Value is 0. Therefore, we have proved that limit of this function is 0. Okay? So here we apply the L'Hospital rule 2 times. We differentiate the function 2 times with respect to y. Okay? So in this way, we can solve the problems of infinity minus infinity form. Whenever it is infinity minus infinity, simplifying the bracket expression will get converted into 0 by 0 form, and then you have to apply L'Hospital rule. Okay? So this completes your infinity minus infinity form. Okay? Now we will go for the next form. Next 3 forms. The next 3 forms are 0 raised to 0, infinity raised to 0, and 1 raised to infinity. Okay, so these are the 3 forms. Procedure for solving the 3 forms is similar. The procedure is similar for solving these 3 forms: 0 raised to 0, infinity raised to 0, and 1 raised to infinity. Okay, so here we will take first form, that is 0 raised to 0 form, where the function is said to be in 0 raised to 0 form if limit of first function fx as x tends to a is 0, limit of second function gx as x tends to a is equal to 0, limit of both the function is 0, and limit of this function fx raised to gx as x tends to a takes the form 0 raised to 0. Okay, takes the form 0 raised to 0. Fx raised to gx, one function raised to another function, if it is given and limit of both the function is 0, then we get 0 raised to 0 form. Limit of function fx is 0, limit of second function gx is 0, then limit of first function fx raised to second function will take 0 raised to 0 form. Then how to simplify this 0 raised to 0 form? So for that, let assume that let L is equal to limit of fx raised to gx as x tends to a. Okay. This is in 0 raised to 0 form. So whenever function is in any one of the form, 0 raised to 0, infinity raised to 0, 1 raised to 0, you will solve the problems using this procedure. Okay. So here, let assume that this limit fx raised to gx is equal to L. Then we will take log of both sides, taking logarithm of both sides. Taking log of both sides. Apply the logarithm on both sides. So here we get log of L. If you take log of both sides, then using the property of logarithm, this is log of L. Limit x tends to a. This becomes gx into log of fx. Use the property of logarithm. Log of a raised to b is given as b into log of L. Okay. So with the help of that, we can write this as gx in log of fx. This function fx raised to gx will be in the form gx into log of fx. So when we take log of this fx raised to gx, this becomes gx into log of fx, which is in 0 raised to 0 or infinity raised to 0 or 1 raised to infinity form. After taking logarithm, that will get converted into 0 into infinity form. Okay. So when we take log, then it will get converted into 0 into infinity form. Okay. So we know how to solve the problems of 0 into infinity form. When the function is in 0 into infinity form, then to take limit, we can solve the problems of 0 into infinity form. We write this function fx into gx as, we shift the term logarithmic term हम numerator में लिखते हैं. So keeping the logarithmic term in numerator, we shift the second function, that is gx, that is log of fx divided by 1 by gx. 1 by gx divided by 1 by gx is same as multiply by g. So we write this as gx into log of fx, which is now in 0 into infinity form, and we know how to solve the problems of 0 into infinity by writing the function gx as log of fx divided by 1 by gx, so that it will get converted into 0 by 0 or infinity by infinity form. Then we can determine the limit of that, okay, using the L'Hospital rule. So if you simplify this, then suppose the limit is, suppose it is equal to b. So we get here log of L is equal to b. Limit of this 0 into infinity form by converting it into 0 by 0 or infinity by infinity after applying L'Hospital rule. If you simplify this, and if the right hand side limit is suppose b, that is some constant, then we get log of L is equal to b. Okay, so if log of L is equal to b, from this we get L value, because we want L. What is L? We assume L is the limit of this function fx raised to gx. So here we are obtaining log of L is equal to b. From this we can write L as e raised to b. Okay, so here write the value of L as e raised to the power b. We write L as e raised to b, and is the limit of the given function. So use the same procedure for remaining two forms, infinity raised to 0 and 1 raised to infinity. If your limit is in any one of the three forms, then take logarithm of both sides. After take logarithm, then limit will be in 0 into infinity form, convert it into 0 by 0 or infinity by infinity, and then apply L'Hospital rule, simplify that. Suppose the answer is b. After solving the problem, if your right hand side is b, then we get log of L is equal to b, and from this L value will be e raised to the power b. Okay. L will be e raised to the power b, so that will be the answer of the given problem. Now we will consider the example on this 0 raised to 0 form. Okay. Evaluate limit x tends to pi by 2. Evaluate limit x tends to pi by 2 cos of x raised to cos of x. Okay. One function raised to another function. one function raised to another function. So here, if you put value of x is equal to pi by 2, this becomes cos of pi by 2 raised to cos of pi by 2. Now cos pi by 2 is 0, so this is 0 raised to 0 form. This is the problem of 0 raised to 0 form. And we know how to solve this. So we take L is equal to. So let L is equal to limit of cos x raised to cos x tends to pi by 2. Now in the next step, taking logarithm of both sides, taking log of both sides. So if you take log of both sides, this will be is equal to log of L, left hand side. This limit x tends to pi by 2. Fx raised to gx, this become gx, that is cos x, into what? Log of cos of x. Okay? Fx raised to gx, this becomes gx into log of fx. Fx and gx are same function, cos x raised to cos x, so this becomes cos x into log of cos x, gx into log of fx. Now, this is in which form? 0 into infinity form. See here, if you put x is equal to pi by 2, this becomes cos pi by 2 into log of cos of pi by 2. Now, cos pi by 2 is 0, so this is 0 into log of cos pi by 2 is 0, and log of 0 is infinity. So now it is in 0 into infinity form. This 0 raised to 0, we convert it into 0 into infinity form by taking logarithm of both sides. So now it is in 0 into infinity form. We know how to solve the problems of 0 into infinity form. Okay, we shift the second function gx in the denominator. We write this as limit x tends to pi by 2 of, keep this logarithmic function in numerator as it is log of cos x, and we write this function as 1 upon cos of x. Log of fx divided by 1 by gx, that is 1 upon cos of x, divided by 1 by cos x, that is same as multiplied by cos of x. Now this can be written as limit x tends to pi by 2 of log of cos of x divided by 1 upon cos x. 1 upon cos x is nothing but sec x. Okay. 1 upon cos x, that is nothing but sec x. And now see the form, if you put x is equal to pi by 2, this becomes log of cos of pi by 2. Cos of pi by 2 is 0 and log of 0 is infinity. Okay. So this is equal to infinity by infinity form. Okay. Board is not properly visible. Hello? Board
Visible,
में
ma'am. Visible. Visible. Visible.
Visible, ma'am.
Visible.
Visible, ना? Okay.
Yes, ma'am.
Okay.
मेरे को नहीं
See
दिख
here.
रहा है
तो रहने दो फिर.
So this is now infinity by infinity form. See here. देख. Limit x tends to pi by 2 of log of cos x divided by 1 upon cos of x. 1 upon cos x is nothing but sec x. So this is limit x tends to pi by 2 of log of cos of x divided by sec x. Okay. 1 upon cos is nothing but sec. And now if you put x is equal to pi by 2, this becomes sec pi by 2. That is infinity, and log of cos of pi by 2, that is log of 0, that is infinity. So now the problem is infinity by infinity form. See, the given problem was 0 raised to 0 form. Using logarithm, we convert it into 0 into infinity form. And by writing this function, cos of x as 1 upon cos x, the function is now infinity by infinity form. Yes. What is the answer? L is 1. Yes, correct. So now you can apply L Hospital rule. So by applying L Hospital rule, we will find out the derivative of numerator and denominator. So this is d by dx of cos x. Derivative of cos x. Yes. Log of cos x 1 upon cos x into derivative of cos x minus sin x divided by derivative of sec x, that is sec x into tan x. Okay. So you can simplify this derivative of this. Sec x is sec x into tan x. Now you can simplify this. Find out the value of log of L. After simplifying this, whatever you will get, that is the value of log of L. So this is equal to log of L is equal to what? Limit x tends to pi by 2 of, this is minus tan x and this tan x. Tan x get cancelled, sin upon cos x tan, and this is tan. So tan get cancelled, we get minus 1 into sec x. Okay, sec x is nothing but 1 upon cos, and cos pi by 2 is 0. So what is answer? This is equal to 0. Left hand side limit is 0, so we get log of L is equal to 0. Since
L is 1.
this is sec pi by
L
2,
is
that
1
is
lakh.
0. So log of L is 0. Log of L is equal to B. Since log of L is equal to B, this implies L is equal to what? E raised to the power B. So this is our B value. So L will be E raised to the power 0. And what is E raised to 0? That is 1. So L is equal to 1. Answer of this problem, L is equal to 1. Okay. So in this way, we can solve the problems of 0 raised to 0 form. Okay. Now for the second problem, you can try this. For the second one, try to solve the second one. Limit x tends to infinity of 1 by x raised to 1 by x. Try to solve this second one. 1 by x raised to 1 by x. This is in 0 raised to 0 form. See, if you put x is equal to infinity, this become 1 by infinity raised to 1 by infinity, 1 by infinity 0, so it is 0 raised to 0 form. So if we assume L is the limit of this, then taking logarithm of both sides, taking log of both sides, we get L is equal to, log of L is equal to limit x tends to infinity of 1 by x into log of 1 by x. Isn't it? 1 by x into log of this function 1 by x. Now we know that using the property of logarithm, log of 1 by x, log of a by b can be written as log a minus log b. So this becomes log 1 minus log of x. Using the property of logarithm, log of 1 by x can be written as log 1 minus log of x. Now what is value of log 1? That is 0. 0 minus log of x, that is minus log of x. So this value can be written as minus log of x. Okay. So this is limit x tends to infinity of, this value is minus log of x divided by x. And now if you put the value of x is equal to infinity here, this is minus sign, take the minus sign outside the limit. So if you put value of x is equal to infinity, this will become log of infinity upon infinity. और 0 into infinity
One answer
form,
आता है
that
क्या?
will be
हाँ 1 आ रहा है.
1 रहता है मिस.
Log of
-1.
infinity. 1 by infinity, 0. Now this can be solved. So this is limit x tends to infinity of, this is minus log of x and divided by x. Now you can apply L'Hospital rule here by using L'Hospital rule. This is in infinity by infinity form. So applying L'Hospital rule, limit x tends to infinity, derivative of log x function is 1 by x, divided by derivative of x with respect to x is 1 here. And if you put the value of x is equal to infinity, this become 1 by infinity and that is 0. So we get here log of L is equal to 0. So L will be e raised to 0 and that is 1. So again answer is 1. Okay. So for this problem, your answer is 1. So in this way, we can solve the problems of 0 raised to 0 form. 0 raised to 0, convert it into 0 into infinity by taking logarithm. And again 0 into infinity, convert it into 0 by 0 or infinity by infinity. And then you will apply L'Hospital rule. For the remaining two cases, that is infinity raised to 0 and 1 raised to infinity, we use the same procedure as like 0 raised to 0 form. So problems on these two types we will solve in our next lecture. Okay. So we will solve the problems of these two indeterminate form in our next lecture. Okay.
Hello, Arif. Hello.